Welcome to the lecture on problems related to the Bessel's differential equation. Already we learned about the series solution of Bessel's differential equations. So in this lecture I am going to discuss about the problems related to the Bessel's differential equation. The first problem is prove that j1 by 2 of x is equal to square root of 2 by pi x into sin x. So by the definition of Jn of x, already we have the formula for Jn of x. That is Jn of x is equal to summation r from 0 to infinity minus 1 power r x by 2 whole power n plus 2r 1 by gamma of n plus r plus 1 into r factorial. So we have to estimate the value of j of 1 by 2. So for that I am going to replace n is equal to 1 by 2 in the entire equation. So if I replace n is equal to 1 by 2 in the above equation, I will get j 1 by 2 of x is equal to summation r from 0 to infinity minus 1 power r x by 2 whole power 1 by 2 plus 2r is equal to into 1 by gamma of r plus 1 by 2 plus 1 will become 3 by 2 into r factorial. On expanding the summation from this equation, so we'll get, so at r is equal to 0, I'll get at r is equal to 0, 1, 2, 3 and so on. I can take directly x power 1 square root of x by 2 common factor. Since I am replacing n is equal to 1 by 2, I'll get x by 2 whole power 1 by 2. It will be equal to square root of x by 2. So it is common for all the equations. I can take common factor. If I replace x, r is equal to 0, I'll get 1 by gamma of 3 by 2. If I replace r is equal to 1, I'll get x by 2 whole square into 1 by gamma of 5 by 2 into 1 factorial and so on. And we know that the value of gamma of 3 by 2 will be root pi by 2 and gamma of 5 by 2 will be 3 into root pi by 2. Gamma of 7 by 2 will be 15 root pi by 8. So this value is obtained from the gamma function concept. This concept we already learned in the previous semester also. So now, and also we have the formula like gamma n is equal to n minus 1 into gamma of n minus 1. Gamma of 1 by 2 is equal to root pi. So from this formula only I estimated the value of gamma of 3 by 2, gamma of 5 by 2, gamma of 7 by 2. Say for example, in this one if I replace n is equal to 3 by 2, I'll get 3 by 2 minus 1 into gamma of 3 by 2 minus 1. So it will be equal to 1 by 2 into gamma of 1 by 2. Gamma of 1 by 2 is root pi. So I will get root pi divided by 2. So if I replace all these values in this equation, I'll get j 1 by 2 of x is equal to square root of x by 2 pi into 2 by x minus x cube by 6 plus x power 5 by 120. So after replacing all these values in the equation, take the common factor as 1 by root pi. I'm taking common factor from the equation and also and multiplying with 2 by x in the complete equation. So I got this equation here, that is x minus x cube by 6. So here I am doing multiplying and dividing with 2 by x. I'm multiplying 2 by x inside and multiplying x by 2 inside the bracket here. So I'll get the equation like x by 2 by x into x minus x cube by 6 plus x power 5 by 120 and so on. So this is nothing but sine series. So here simplifying it. So this 2 by root 2 will become root 2. Root x by x will become 1 by root x. So I got the equation like square root of 2 by pi x into sin x. This sin x is obtained from the sine series from this equation. Similarly, prove that j minus 1 by 2 of x is equal to square root of 2 by pi x into cos x. So same like previous problem. So take the definition of Jn of x. So Jn of x is given by summation r from 0 to infinity minus 1 power r x by 2 whole power n plus 2r into 1 by gamma of n plus r plus 1 into r factorial. So now to estimate the value of j minus 1 by 2, I am going to replace n is equal to minus 1 by 2 in the above equation. So I will get the equation like j minus 1 by 2 of x is equal to summation r from 0 to infinity minus 1 power r x by 2 whole power minus 1 by 2 plus 2r into gamma of r plus 1 by 2. So if I replace n is equal to minus 1 by 2, so minus 1 by 2 plus 1 will become plus 1 by 2 into r factorial. So on simplifying that equation, we'll get j minus 1 by 2 of x is equal to square root of 2 by x I'm taking square root of 2 by x common factor. Since I'm having n is equal to minus 1 by 2, I'll get the equation like x by 2 whole power minus 1 by 2. On simplifying it, I can write that as 1 by x by 2 whole power 1 by 2 I can write it, or square root of 2 by x I can write it. And on simplifying it, I will get 1 by gamma of 1 by 2 minus x by 2 whole square 1 by gamma of 3 by 2 into 1 factorial and so on. So again, on replacing the values of gamma of 3 by 2 as I did in the previous problem, gamma of 3 by 2 will be root pi by 2, gamma of 5 by 2 will be, and gamma of 1 by 2 values in this equation. It will be equal to, I can take 1 by root pi common factor after replacing all these values. So I will get j of minus 1 by 2 of x is equal to square root of 2 pi x 1 minus x square by 2 factorial, x power 4 by 4 factorial, and so on. I will get it. So this is nothing but the cos series. So we'll get j minus 1 by 2 of x is equal to square root of 2 pi x into cos x. So next, prove that integration 0 to pi by 2 square root of x j 1 by 2 into 2x dx is equal to 1 by root pi. So already we have the formula for j1 by 2 of x. So j1 by 2 of x is nothing but square root of 2 by pi x into sine x is the formula we are having. Actually, I want the formula for j1 by 2 of 2x. So in the j1 by 2 of x formula, just replace x is equal to 2x. So we'll get j1 by 2 of 2x is equal to square root of 2 by pi 2x into sine 2x. 2 gets cancelled. I got 1 by square root of pi x into sine 2x. So now I want a function like root x into j1 by 2 of 2x. I'm going to multiply root x on both the sides. So I will get root x into j1 by 2 of 2x into root x into 1 by root pi into root x sine 2x. So root x gets cancelled. I got root x j1 by 2x is equal to sine 2x by root pi. So now I'm going to apply integration on both the sides. So integrating both the sides of the above equation, I'll get integration 0 to pi by 2 root x j1 by 2 into 2x dx. So it will be equal to integration 0 to pi by 2 sine 2x by root pi dx. Since 1 by root pi is a constant, I can take outside. Integrating it, I will get minus of cos 2x by 2. So applying the limit here, applying the upper limit, I can take minus 1 by 2 outside. So applying the upper limit, cos 2x will become cos 2 pi by 2, pi gets cancelled, 2 gets cancelled. I will get minus, so I will get cos pi here. Applying the lower limit 0, I will get cos 0. So cos pi will become minus 1 and cos 0 will become 1, so it will become minus 2. So 2 gets cancelled. On multiplying it, I will get root pi. So I got a solution like integration 0 to pi by 2 root x j1 by 2 into 2x dx will be equal to 1 by root pi. So we'll see one more example on the problems like j1 by 2 dash of x into j minus 1 by 2 of x minus j1 by 2 dash of x j1 by 2 of x is equal to 2 by pi x. So we have the formula for j1 by 2 and j minus 1 by 2 also. So first I am taking j1 by 2 of x, that is square root of 2 pi x by into sine x. Since I need j1 by 2 dash of x, I am going to differentiate the equation with respect to x. So if I differentiate the equation by using product rule, first I'm taking the constant square root of 2 by pi outside. Differentiating sine x, I will get cos x by keeping root x as it is, plus keeping sine x as it is, differentiating 1 by root x, I will get minus 1 by 2 into x power minus 3 by 2. So on simplifying it, I got j1 by 2 dash of x is equal to square root of 2 by pi x cos x minus sine x by 2x. So on taking root x common factor, I got this equation. Call it as equation number 1. Similarly, take the equation for j minus 1 by 2 of x also. It is given by square root of 2 by pi x into cos x. So differentiating this equation with respect to x, we get j minus 1 by 2 dash of x is equal to square root of 2 by pi. So again by applying product tool here, keeping 1 by root x as it is, differentiating cos x, I will get minus x. So keeping cos x as it is, differentiating 1 by root x, I will get minus 1 by 2 into x root x. So by taking root x common factor, I will get j minus 1 by 2 dash of x is equal to minus square root of 2 by pi x sin x plus cos x by 2x. I got it. Call it as equation number 1. Equation number 2. So now we have to satisfy this condition. So multiply j1 by 2 dash of x with j minus 1 by 2. Subtract it with j minus 1 by 2 dash of x with j1 by 2 of x. So we'll see what is the answer. We'll get it. So on multiplying the equations now, I got the equation like square root of 2 by pi x cos x minus sin 2x by 2x into square root of 2 by pi x cos x, again square root of 2 by pi x sin x plus cos x by 2x into square root of 2 by pi x sin x. So since here I can take the common factor as 2 by pi x. So after multiplying this one with this one, I'll get 2 by pi x. Same thing here also, I got 2 by pi x. On simplifying it, I'll get cos square x here minus sin 2x cos x by 2x, sin square x here plus sin x cos x by 2x. So actually it is sin x. So on simplifying it, these two terms gets cancelled. I got cos square x plus sin square x, so it will be equal to 1. I got the solution like 2 by pi x. So this is the required result for the given condition j 1 by 2 dash of x into j minus 1 by 2 of x minus j minus 1 by 2 dash of x, j 1 by 2 of x is equal to 2 by pi x. Thank you.